many know what Azure is? Okay. How many they're actually using it in production? Yeah, that's always like that. Okay. How many are actually planning to use it in production? Okay. So the rest that didn't raise the hand, why are you here? You're an IT guy, you don't count. I've been to your boring Fabric stuff, so you come to my boring stuff now. So, I'll start, and as people come in, well, today, well, first let me introduce myself. I have that difficult name. You can just call me Panos. I have nothing to do with the sandwich company in Belgium. And please don't make jokes about it. Everybody does this to me. You can follow my Twitter. I usually say that it's purely around Windows, Azure, and stuff like that. You're not going to get tweets for, I don't know, if Rihanna had gone back with Chris Brown or whatever. And today's talk is about caching for cache or cache to save cache. It's a nice word trick we use. Usually, whenever we refer to caching, we have some things in mind. We have, first of all, improving the latency. So, no more round trips back to the database, and some other scenarios that you will see. It's not, a lot of people think that it's only, yeah, I won't have to hit the database, I will hit the local cache or a distributed cache or something like that. It's not only this, okay? And the whole purpose of this talk is not only the AppFabric caching service, but how do you actually lower your latency in your application in general? Okay, so it could be like caching, it will be like the CDN, it will be like some patterns that you can use, and yeah, whenever you have questions, you can either stop me, or as I said, the presentation is a little short, so I won't take much of your time. Yeah, usually it doesn't work that way, but anyway. So, whenever you hear the word low latency, what comes into your mind? You can just shout, it's just free, whatever you think. Whenever we say low latency, what do we mean? Speed could be one, yes? Anyone? Okay. So, whenever you say low latency, we mean quick response or quick result. Okay, so either we get the quick response, it doesn't matter if it has to be the result or not, or we just give a quick result, which could be actually a combination of both. A quick response equals a quick result, or it is a quick result. For example, whenever you go to Amazon and you buy something, you get both of them. You get a quick response, thank you for your order, and you get a quick result. We actually took your order. Okay, then the order will be processed at some time later, and you'll get a notification by email or something like that that will say, yeah, thank you very much, we took your beautiful money. This, the product will be shipped in 1 or 2 or 3 days. You will get your tracking number by then. But what quick response actually means? Quick response actually means higher customer satisfaction. Okay, so the quicker you respond, the more satisfied your customers will be. It's a more intuitive UI. You get the response instantly, even if it's not something that, for example, in the order, you don't know if the order is going to be shipped. They just know that they got the order. But you don't care. At the moment you feel that the system works, you got the reply you should, and if something goes wrong, you will get another reply or another email or something like that. And of course, higher customer satisfaction means more money. People will come back. If you have, like, again, I'm using Amazon because it's a very common, a very well-known shop. Okay, it could be Big's Money, I don't know. But the whole purpose is that higher customer satisfaction means more money. Okay, people are coming back, they're buying more, they feel like they're part of the process and all that stuff. So, challenges today. How do you actually do that? Okay? First of all, you need to scale your application as the load increases. Okay, so how do you do that? When you have peak sessions like Christmas and, I don't know, Easter, or a discount session coming 1st of July until end of July or something like that, how do you actually react to that peak? And that could be, as you've said, you either scale up or you scale out. It depends on the process, it depends on your software, it really depends on a lot of things. But today, we're about how do we combine all those to lower our latency, our response times. Second of all is get better performance and reduce data access latency. So whenever you have like a product catalog, you don't have to go always and ask the database if there is a new product catalog. It's usually always the same, and it changes twice a week or once per month or something like that. Whenever it changes, then you need to get that information back. Okay? Until then, you don't need to go all the way back to the database. How do you store aggregated data? You have data from a database, you have data from a node data service, you have data from a local XML file, and you combine them all together. How do you avoid doing that thing, doing the combine process every single time? Every single time that someone goes to your page, you have to avoid doing all that. Why? First of all, round trips to the database to get the data from there. Round trips for HTTP talk to get the data from an old data service. Disk I/O if you want to get the information from an XML file that relies on your local disk. How do you have and how do you actually manage your ASP.NET session state or the page output cache? Okay, this is something that for web developers in 101, whenever you want to do something really serious, you have to know how to do that. A lot of them use caching either using third-party tools, or they do it by themselves, or they have their own implementations and algorithms and stuff like that. So, that's some of the challenges, but the most important one is how do you avoid building, managing, and actually deploying a system that does all that. So what do you need? There is a keyword in here. It's called distributed caching. Okay, what is a distributed cache? We'll see a little later. Do you know what the distributed cache is? How many of you know? So, possible solutions to all that stuff. As we said, highly scalable distributed memory cache. Okay, how does it work? It either has the local in-memory cache, which is not fast. Okay, it goes like that. Just works. And as we're talking about cloud applications, and you will see, usually people ask, yeah, can I use it on-premise? Yeah, you can, but you'll see why it's not a good thing. So that cache is located near your application. So it's living on the same data center that your application is. And it also respects your affinity. Do you know what affinity is on Windows Azure? Okay. So affinity means that I can group a part of services, and all of those services have to be as close as possible. Okay? So whenever you create an affinity group, let's say, I don't know, affinity 1, and you put a storage account and 2 roles in there, what the Fabric controller will try to do is have all of them as close as possible. Okay? If you also have a caching service, the caching service will try to respect that and put it as close as possible. So that means even within the same data center, they will try to lower your latency to hit the cache or hit the local storage or stuff like that. So instead of doing, I don't know, 10 milliseconds to go to the storage and the cache, you will do 6 milliseconds or 8 milliseconds or something like that. Okay, so it respects your affinity. There is no administration. You don't have to deploy it. You don't have to create it. You don't have to manage it. You don't have to build it. And you only pay for what you use. Okay? So that's something we want. We don't care about anything. We just want to use it. Okay? And the last thing is easy integration. You want that to be integrated easily into your existing infrastructure, into your existing application. If you're using Windows Server AppFabric cache, going to the Windows Azure AppFabric cache is fairly easy. It does have some limitations, we'll see those, but it's the same API with a different underlying infrastructure. So, there you go. Windows Azure AppFabric cache. Okay, that's the solution to all of those. And now some marketing fluff. Distributed in-cache memory for the Windows Azure applications. You can also use it on-premise. So yes, you can access the Windows Azure distributed cache from an on-premise application. But that defeats the whole purpose of actually trying to lower your latency. The latency is going to be high anyway. Okay? It doesn't make sense to do that. Except if you want for some reason, I don't know. You can dynamically increase and decrease the size of that, and it's based on the Windows Server AppFabric cache. Okay, so this is something, if you remember, that was called Project Velocity, and it was merged all together with Project Dublin, and you got AppFabric, and then you got AppFabric cache and composite applications and all that stuff. So, going a little further, some features of that cache. Okay? Simple administration. You don't have to do anything yourself. You just create a namespace. We'll see how we do that. And then you change a bunch of configuration lines. You use it in the code. If you use, as I said, if you use Windows Server AppFabric cache, it's fairly easy to change it. If you don't, then introducing a caching layer, it's also very easy. You change some configuration, and then you just use the correct lines of code, and that's it. We said we need easy integration, right? We do have that. We had out-of-the-box ASP.NET, session state providers, and page output caching. So the configuration works out of the box directly. You just change the lines into your web config, and then it uses the cache instead of using, I don't know, whatever you had, like a session state server or improc or whatever it was, your previous solution, or even a custom provider for your session state. As I said, it's the same interfaces. Okay, it's the same thing. Whatever you see on the first one, it exists on the second one. It doesn't mean that it's implemented, but the API is the same. So, on-premise application, you have your call logic, AppFabric cache API, Windows Server AppFabric. Now, the cloud application is the same thing, but the underlying infrastructure is the Windows Azure AppFabric cache. Okay, but the API is the same. Last, you can cache any serializable managed object. It's incorrectly stated that there is no object size limit. There is an object size limit, and it's 8 megabytes. Okay. Sometime it will change into the documentation. Whenever you see no limit, there is a limit. It used to be no limit. For some reason in the RTM it's 8 megabytes. It will probably rise, go away, I don't know. But the thing is that there is a limit, okay? We also provide the way of near cache client, so you can cache hot data, as we said, a product data catalog or something like it, on your local memory, and then you can access it from there directly. And last, it can be secured by the access control service, okay? You know what the access control service is? Anyone? No MVPs, dude. we know you know. So, okay, access control service. Very quickly is a way to manage identities on Windows Azure, and it's a way to authenticate people using various standards against your service, against your application. That's very, 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 very high overview. Okay. That means that whatever you secure using ACS on the rest of the services, you can use it to secure your cache. So who can actually have access there, what they can do, and all that stuff. Latency pyramid. From where do we start and where do we go? So the one that is the most slow is, of course, the disk. Okay? Disk I/O is the most, it's the slowest thing you can get on an application whenever it comes to accessing stuff from there. Then you go to the network. Okay? It's less slow than the disk, but it's still slower. it's still a little faster. And then it's memory, which is the fastest of all. And how does that stack applies to the actual abstractions? First of all, highest latency is the storage. So if you use any kind of storage, Windows Azure storage or your local storage or whatever, disk is the one that takes more time to respond. Okay. Second one is lower latency is the actual distributed cache. Okay. So the Windows Azure AppFabric cache, the distributed cache, not the in-memory cache, you have local. That means your local data cache. The distributed cache runs on the network level. It has lower latency, but it's still slower than the memory. And then you have the local cache, which is the fastest of all. Okay, so things that are living locally in the memory, of course, they're the fastest of all. In-memory caching. First, what can you actually store in there? You can, as said, for example, put your product data catalog in there. Okay, so you don't have to go back to the database and get the information from there. You also can put your session state. Okay, a shopping cart or data that they don't change that much, you can put them in there and reuse them from there really quickly. So that's how it looks now. You have a client, you have the hosted compute that accesses a SQL, Azure database, and table storage. This is whole. And this is an example of aggregated data. You get some data from SQL Azure and some data from table storage. As soon as you do that, you can introduce in-memory caching. So now the application is hitting the in-memory cache that has all the information from this, the information that you said it should have from SQL Azure and table storage. Don't do anything funny and try to put like the whole database tables or something like that into cache. Okay? Even if there is no object size limit, it's not a very good thing because it will cost you tons of money. So, by introducing a caching tier, you lower your latency, you raise your throughput, and you also lower your cost. Why? No transactions to the database, no traffic, faster response, and all that stuff we said. Okay, higher customer satisfaction, blah, blah, blah. How a distributed cache looks like. Okay? First of all, we have multiple instances that may be cache clients. So in-memory cache, local cache can be in each one of the instances. Okay? Then you have something that it's reflected, it's abstracted as a namespace in Windows Azure AppFabric cache. We'll see how we create that. So you have a unified cache view. So all of the clients, they hit the same namespace, they hit the same classes if you want, and they request information from there. And then you have the actual distributed cache layer. Okay? This is where the magic happens and you don't care about it. You, for example, it could be that the first time you get information from the first role, you hit the unified cache view, then it goes to that node, and then it's replicated to all of the nodes, and if one of the clients requests that information, it will get the latest information. The things that you have to be careful about caching is that you have to think when your cache will be evicted, so when an actual object has to be removed from the cache, or when it has to be updated. The people who are familiar with Windows Server AppFabric cache, they say, yeah, that's easy, we use notifications. Yeah, okay, but that's not supported in the Windows Azure AppFabric cache. So you do have to put like a timeout on your on the objects you put in the cache, so they will expire after some time and they will be forced to be reloaded. Okay? You have to find like a balance between all of those. Okay, so sounds nice, I hope. How do I actually use that? Steps to introduce caching. You have to go through some very, very simple steps. First of all, you have to go to the portal. Okay? And after you go to the portal, you give a name to create that namespace. You select where the namespace should be. So what data center it should run. You select the size, the total size of the cache. It can be from 128 megabytes up to 4 gigs. Then you just wait for a couple of minutes. It can take from 5 to 15 minutes to provision the cache. And at the moment it's ready, you can just take the configuration from there. If you want, and if it's desired, you can assign that with an access control service. Okay? And this is the actual configuration. At the moment you create the cache, in the portal you will see you have a nice button that auto creates your configuration for you. Okay, so you can just take the configuration from there and just replace it on your web config, and that's it. Okay, this is if you use the AppFabric cache already, or if you just want to change your session state or your page output caching. Okay. In case you want to change the session state provider, this is the configuration. Okay, so you change to the custom, the mode to custom. It shouldn't be in proc session state server or whatever. It has to be custom. You select the actual provider. Compression enabled. That can be. You can choose if it's going to be enabled or not. You can enable for session state of .NET 4 ASP.NET applications. You can enable compression on the data object level. Okay, so the object that actually goes into the cache, you can enable compression of that. It's enabled on the data cache client. And it has a bunch of other properties. The ones that are actually important is the cache name. So if you have multiple caches, you might want to choose a different cache name. So whenever you try into the code, you'll see it's 2 slides later. Whenever you try to load that, you might want to load from a different cache instead of your default cache. Okay, and the application name, so you know which application if you want to programmatically access the application name. This is the caching output provider, so this is what you have to change for the output cache. It's the same concept. You change the default provider, you give a custom provider that works with the Azure AppFabric cache, and that's it. Now, caching code. Cache factory. It's the same. It's almost the same concept like every other Azure service. You need to create a factory. From that factory, you get a client, and then from that client, you get all the methods you need, all the classes, all the interfaces to use the actual service. So first you create the factory, then you create the cache client. After you create the cache client, you can see that it says get default cache. Okay, that will take the cache with the default name. You can get a cache with a custom name unless you can use a different overload, or I think it's a different method that you get the cache with a specific name. Okay. Then you just put that super cool object into your cache. Okay, and of course you give the key of that object, so it can distinct which one it is. Then if you want to retrieve it, you just retrieve it back, get the key of the object, you take it back. So the key has to be unique, of course. And in case that object doesn't exist in there, it means that it's not on the cache or it has expired from the cache. Okay, so there you do all your logic, and at the end you just add it back to the cache. Now the get and the put and all of the methods, they have different overloads. For example, the put method has an overload for the timeout, or if there is a retry policy. And just be careful that because the overloads are the same as the server AppFabric has, be sure that you don't use a feature that it's not supported, because at the moment you will try to run it, you will get an exception that the feature is not supported. Okay, so even if you see the actual enums or interfaces in there, if it's not supported, if it's documented that it's not supported, it doesn't work. As I said, it's just that the API is the same, and that's the reason. There is a reason for that, and the reason is that it's going to be the same. So whatever works on the server AppFabric cache, it will work on the Azure AppFabric cache. Okay. Cool. Don't expect something very fancy on the demo. It's just I'm going to show you the portal. Yeah. And how do you actually create a cache? Cool. Ah, that was not very clever of me. Nope. Yeah, it wasn't loaded. Thank you. So, damn. Just a second. Good. So, you choose a name. You choose a name. Well, I could just have been to cache and then choose the name from there. And anyway, I just don't want to change the configuration of the projector loses my resolution and I have to do all that stuff again. Anyway, so you just give a name and let's say, I don't know, super duper cache. You choose a region. So, where is it? Europe North. And yeah, it goes in my MVP account. And then you just choose the cache, the total size of the cache. Okay, you can change that once every 24 hours. So even if you choose something that you don't want now and you want to scale down or up, in the next 24 hours you can change it. And it's funny because if you try to, let's say 1 gig, no, 1 gig is too much. So I'll create the namespace now. Yeah, I have other caches for fun. So it says activating at the moment that it's activated. You can get the configuration. Those nice buttons up here are going to be enabled. I will just wait for it to activate because I want to show you something. Let's hope it won't take 15 minutes or 5 minutes. Usually it takes 1 to 2 minutes, but anyway, I'll show you the first one from here. So the access control service, I'll get the redirection and enable whatever I want to protect the application from here. But now, let's go back. So if you come to, let's say, this cache, you can see the configuration created for you. If you click that button, it will just pop up and give you the configuration out of the box. Okay, so you can just copy paste that and use it into your cache. To use the cache, you can copy paste it into your web config and you're done with that. And what is also interesting is what I said, you can change the size. Okay, this is a 4 gig cache. You can say that it's 256. Let's do that to 256. Now, if I try to change that, it won't let me change it in the next 24 hours. Okay, so as soon as 24 hours are done, you can change the size of the cache again. Come on. Sorry, no code. And so what it's not supported, things that you cannot use. First of all, you cannot use notifications. Okay, notifications are not supported. In case you you want to, as I said, somehow be safe, whenever you put an object into your cache, give it a timeout also. Okay, expiration and eviction, by default, it doesn't expire. An object that goes into the cache, it doesn't expire, unless you give an expiration time, which is, of course, respected by the cache. And eviction means that objects generally are not evicted if you don't remove them by yourself. Okay? But in case that the cache size gets over the limit, then all the new objects that are going into the cache will remove the last recently accessed objects. Okay, so those will be evicted; they will be removed by the cache. High availability, the feature it's not supported, and regional tags are also not supported. So you cannot create your own user region tags, regions, and tag objects and do tag-based search and stuff like that. But all of them are on the roadmap. Okay, we cannot say when, but some of them are going to be soon, some of them are going to be a little later, but all of them are on the roadmap. Okay, so they're going to be implemented. But I also said something about low latency applications, and this is the part where I go a little faster. So, Windows Azure CDN. Now, the funny thing about CDN is that some people say it's content delivery network. In some slides, Microsoft says it's content delivery network, and in some other it says it's content distribution network. Okay? Whatever you say will mean the same. CDN is content delivery network, content distribution network. It doesn't really matter. CDN is a way to put your blob storage data all over the world in 24, and it will get even more. I think it's 25 now or something. Locations around the world. You can put your blob, your public blob objects there. Okay? And what is even cooler is that there is a way that you can use CDN to distribute content that lives within your role. Okay? So things that are not necessarily on the blob storage, but they live inside your role, like CSS files or pictures or whatever, you can actually put them all on the CDN also. Okay? You can, as soon as you enable them, you have two different URLs, the original URL and the CDN enabled URL. Okay? And you can create your own custom CNAMEs for those. Makes sense? Now, Steve Marks has a nice blog post about how you can do adaptive streaming, but smooth streaming is already in CDP, and at some time, they said by the end of 2012, it's coming. Now, what I'm not sure is if this is a calendar year or if it's fiscal year. If it's fiscal year, it should be like within the end of June or something, but I don't think. I think it's by the end of the year, the calendar year. Anyway, so native smooth streaming is coming. If you want to do that before, with a custom way, you can use adaptive streaming, following the post by Steve. Windows Azure CDN, what it does. So it takes all that stuff and puts it on different edges. Okay, so we have like the data centers, you put your content in there, and then it's distributed around on the edge. But how does it actually work? Okay, so you have blob storage, you have a public container, you have your stuff in there. Okay, your public container is called X. Now, you enable CDN on that container, okay? And at the moment you do that, it means that you have fewer hops to get to the content, okay? Because the content is closer to you based on the edge. Now, you have to be a little careful because sometimes this is not true, okay? Sometimes you're routed to the CDN for some specific countries, but it's not closer, it's not faster, okay? Just make sure that you do a couple of trace routes and you find if it is or not, okay? For example, for a country that you all hate right now, and I come from, usually if you enable CDN, it doesn't work faster than accessing the Amsterdam data center directly. Okay, we go through Romania, but Romania is not faster than accessing Amsterdam directly. So, closest point of presence This is the edge node where your actual content lives now. The DNS name resolves to the closest POP. As soon as you try to access that container, then it goes to the blob storage. First, it sees if it's on the CDN. If it's not, it goes to the blob storage. It copies that back and then serves the content to you. Okay? Now, the next guy who's going to access the CDN, it will take it directly. To be removed from the CDN, if you've seen, it says that it respects the HTTP header with... let me show you that again. So, time to leave is determined by the actual HTTP header. Okay? So, reduces latency. You still have all of your stuff on a central location, and it just gets propagated everywhere. A common question is, how long does it take to propagate, and how do we actually invalidate the CDN? Both questions is we don't know. Okay? Usually, it takes to propagate it everywhere. It takes either on the first request, or it gets. I think it's up an hour or something. I'm not sure of that. But the reason to be removed is, as I said, if it expires by the HTTP header. If there is no HTTP header, it will be removed at some time later. So, patterns to improve latency. How do you make things go faster? Okay? I think it's like, yeah, I have 4 more slides and you're done. So, first of all, synchronous design pattern, and why this is not good. At least not always. It really depends on the application. First of all, you block the actual threads that do the work, okay, which is not a good thing. Because if you have a web app front end and you have a thread and then a client requests something, at the moment it requests something, then a new thread opens up on the work thread, if you like. Now, that is accessing whatever it's needed, your middle tier, your business logic, whatever it's needed, okay? Now, all that time, that thread is blocked, okay? And nobody can actually come and request something else, okay? So, he's just waiting, client who's just waiting. At the moment you get a response, then the thread, the thread is unblocked. The client gets the reply, and the second one can go on with his processing. This is not a good thing if you want to serve millions of users, okay? But it is a good thing if your application absolutely needs to do that. So if your application has a reason to be absolutely synchronous, then you have to use multi-threading, not just a single thread. You have to use multi-threading to do that, okay? Now, in case that you don't care that much, and you can change the logic, you access your data and you do whatever you do, then you can use an asynchronous design pattern, okay? So that means that the work is offloaded to, the work is not actually being processed at the moment you access the page or the front end or whatever. What actually happens is that you queue that work, okay? Thread, request to the middle tier. This is the same up to that point. Now, at the moment this is done, that thread creates a context in the middle and puts that callback there and just waits for an answer. Okay, so there is a callback waiting for an answer from that specific thread. Now, that thread now is unblocked, okay? So it can process more requests. For the second request, we do the same thing. So we invoke a second work thread. We create a context and a callback for that. We put the callback there. And now we have a thread that is also free to process information or wait for a callback or for another client request or whatever. Now, if you combine that with multi-threading, then you're limitless, actually. So the response comes. It checks, yeah, that response should go where? It should go to client 1. Okay, so it gets the context from client 1 and returns the response. So it finds the client and returns the response at the moment. just be careful with Windows Azure if you do that, because if you keep the asynchronous channel open without a keep alive method, it will close after 59 seconds. Okay, the load balancer doesn't allow channels to be open for more than 1 minute. Okay, so if you open a callback and it takes more than 1 minute to take a response, you have to implement a custom keep alive to keep the actual channel, the callback channel open. Okay, otherwise it will close and it will fail. It will never get the callback result. Same thing goes now. Okay, we have a second response. The thread, a thread picks it up, does all the checks we said, and returns the response. Clear? Hope so. Okay. But as I said, just remember that you have to be careful with that 59. It's actually 60 seconds, but on 59 it fails because the 60th second is coming right after. So client requests are being tracked inside your code custom. Even on WCF, the callbacks have to be tracked into a data structure that you create on your own. It's never automatically, okay? Unless the wrapper does the unsigned callback and all that stuff. But if you do that, then it's not that easy to implement your own keep alive strategy, okay? You have to go a little dirty with WCF. So keep in mind that the local thread is not durable if you don't make it durable by yourself. So you can maybe use a cast somewhere in here, or for some reason introduce a way to make that information durable. That means that if it fails, it can resume. Okay? And of course, as we said, we block less threads for that. Okay, so it means more processing. In combination with multi-threading and .NET 4 parallel computing and everything, yeah, you can do magic within your workers or whatever your application in general. So, asynchronous cloud apps, the same concept applies on both cloud apps and on-premise applications. Okay. Queues are useful to do something like that for asynchronous communication. So you can either use that callback thing we said, or offload it to a queue, so the worker role will pick it up from the queue, do the work, return the result somewhere else, and the client will just check every couple of seconds, I don't know, 15, 30, 1 minute. It will check if there is a reply for him, and if there is a reply for him, it will just take it back. Okay? A usual thing we do is we put it on the queue, a worker does all the computation, the actual work, and then it puts the result into table storage, and the client just requests with a unique key from the storage, if there is a reply from me, what is the reply? And the actual reply might be, if it's a processed image, it could be the actual blob storage URL, or it could be the result directly into the table storage, or whatever you like. The good thing is that Azure Storage has built-in load balancing, and it doesn't care if something goes wrong into the internal stuff. It's always guaranteed that you get the information you want. Last things and stuff that support asynchronous calls that's on Microsoft technologies, .NET Additive Framework, WCF Data Services, Link to SQL, even the plain old .NET supports asynchronous calls. Okay, so whatever you see that has the assign keyword at the end of a method, it means that supports asynchronous calls.